The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW.
And welcome back to the show. Real quick, before we get to our technical segment, we've recently added the State of Security Education and Training webcast with IT Pro TV and Roger Williams University to our content available on our On-Demand series at securityweekly.com/on-demand. And upcoming conference for some of the Security Weekly folks, InfoSec World, March 19th through the 21st in Lake Buena Vista, Florida. And Security Weekly subscribers can save 15% off the InfoSec World Main Conference or World Pass with the code OS18-SW. Excellent. All right. Coming back to the show for his, I don't know how many appearances, but it is always a treat when Sven from Netsparker is here. In fact, every time Sven is on the show, I am texting some of my coworkers and say, you guys need to listen to this because Sven's blowing my mind. So
it's nice to be here. I think it's the fourth time.
I think so. And for me personally, every time you're here, Sven, I am learning a ton, and I feel the need that I need to specifically share your stuff because it's so awesome. So,
thank you very much.
So Sven, welcome back, and I'm going to turn it over to you and let you talk about same origin policy. But I know you have a much sexier title for it than that.
Yeah, it's actually same origin policy, and I called it how to circumvent the same origin policy and how to get hacked in the process. So. The problem with the same origin policy is that it's quite restrictive, which is a good thing for a security policy, but like almost every good security measure, it comes with some disadvantages for usability. And that's why the browser vendors decided that you can actually lift some of these restrictions in order to allow different origins to communicate with each other. But there are some pitfalls, and I will show you a few of them.
Sven, this this sort of reminds me of the old joke that we used to say is that a totally secure computer is one that's turned off and buried under 8 feet of concrete or something of the like. But it's totally unusable. So same origin policy is a really great idea, but when you do it securely and with absolutely tightened down, it potentially effectively becomes unusable. So you have to make some allowances.
At least for very, you would have a very restricted user experience actually. And if you want, I can share my screen now and tell you a little bit more about it.
That'd be great. Here it comes. Whoa! Hey, look at. Oh, that was cool.
Infinity Larry.
I love that. I love that.
Okay, so as I said, I called my talk "How to Circumvent the Same Origin Policy and How to Get Hacked in the Process." And let's talk a little bit about what SOP actually is. And it's been around since 1995. And it's one of the most important security policies in web browsers. It isolates documents from each other if they were retrieved from different origins. What different origins are is kind of, I will explain it in another slide. And of course, it's hated with passion by many web application developers because it's just so restrictive. And yeah, as I said, so I will give you a little crash course on what the same origin policy is and what is considered the same origin. So there's not a single standardized SOP. It's just that it developed over time. And generally, origins are the same when these properties match. First, we have the protocol, HTTP, HTTPS. Then the host name, for example, example.com. And we have different ports that need to match in order to be considered same origin. By default, cross-origin websites aren't allowed to one of the disadvantages of the same origin policy. They DOM, and they can't set custom headers when they send requests to each other. It's also not possible to use get. It's also only possible to use get and post, but you can't send, for example, put or delete requests. And with that in mind, I will show you a few URLs, and you can probably already spot which ones are same origin, but maybe you can't because it's a little bit complicated. The first one is this, http example.com/blog, and the other one is http example.com/about. Then we have https example.com, https www.example.com, and https www.example.com and http www.example.com. So if you paid attention, you will probably notice that the first one here is actually the same origin. It is port 80 by default. It's HTTP, and also the host matches the host name. Then we come to a problem here because obviously if you own example.com, you probably own www.example.com and want to communicate with it, probably. And the problem is it's a different origin, actually, because it's not the exact same host name. Just, yeah. And here's another problem. HTTPS and HTTP also not same origin, even though everything else matches. So, as I said, good security measures come with a cost, and SOP is a good security measure, actually. But what can you do if you want to allow sites from other origins to access your data? There are different ways to do that, actually, and all of them can be implemented improperly, which we will see in the demo. There's JSONP, for example. It's just JSON in a certain format, actually. Then we have cross-origin resource sharing, in short CORS. It's an HTTP header. We have document.domain, which involves changing a value using JavaScript. And we have postMessage. It's a JavaScript API. However, there are also other ways to do it, like cross-domain.xml proxies or WebSockets, but we aren't going to talk about them today. Instead, I will give you a little demo. Okay, is that visible for you?
Yes, sir.
Okay. Yes, what we can do here is it's just a simple site. We can log in here. And that is it. So that's all it does, actually. But if we look at the network requests, there are quite a few of them. It's probably because of the the next level design of the page. Involves a few resources to be loaded.
Yep.
But what we want to look at is the get user PHP file. Let's open it here. And what you can see here is just simple JSON. I think every one of you has already seen something like that. It's a pretty convenient format. It's human readable and machine readable as well. It doesn't have much overhead or anything. So this by default is very secure. Actually, there was an exploit called JSON hijacking a few years ago, but that was fixed, and you can generally say that it's quite secure. You can't you can't read that from another page. However, that is also a problem sometimes, because you want to make some things accessible, some data. And what you can actually do is use this highlight the JSON again. And all this does is actually writing the name of the callback function here and put that in parentheses, the JSON object. However, what we can do now is, this is the very well designed attacker page. What we can do now is just steal the data actually. And how that works is quite cool. Because let's just look at the source code here. What we do here is actually defining a function called ASD, like in the example I just gave you. And what this does is just it handles some data here, then selects this div element, and then writes the data into the element here. After that, it will just open the include the page that we just saw with the script tag. And if you look at this is actually a valid JavaScript function call, the ASD and the parentheses here. And that means that the ASD function is called with that JSON object. And therefore, we can read it here. It's actually meant as a way to circumvent the same origin policy. But if you are not careful, you may expose sensitive data like this. And the reason why this works, why you can just call this here, is because JSON is also called JavaScript object notation. Because obviously, if you would write an object in JavaScript, it would look exactly like this if you would write it inline there. And that's why it works. So it's just passing this object to the function there. But that's not the only thing that's wrong here. So let's look at cause. If we want to exploit that, it worked again. So why does it work? You can see here the access control allow credentials header. It's true, and access control allow origin is http attacker.ns. So this is our attacker side. And the problem here is that cause actually kind of disables SOP for the host that we specify here in the access control allow origin header. Why this says attacker.ns, and this seems to be quite far-fetched, that a website would actually have this host name in their cause implementation. This is due to the fact that you can't use a wildcard here, and developers like to use wildcards everywhere where it's possible because it's just convenient. And this doesn't work if this is set to true. This just allows that cookies are sent together with the request. And that's why many developers, actually it's more often than you might think, just will mirror the origin into this header. So this quite defeats the purpose of cause, actually, or the same origin policy, and is still quite common, unfortunately. So, whoops. Yeah, let's close that again. What we can also do is, this is quite interesting. Let's select that, and you see we are now on subdomain.volensite.com. This only works if we are on the same, if this is the same main domain, and we have JavaScript execution subdomain. Exploit this here. We also we will get an error that just says that it blocked a frame with origin subdomain across origin frame. So yeah, this doesn't work. But if we actually do this, we set document domain to the main domain here, onesight.ns, then we can suddenly read the whole HTML source. This is due to the fact that if you set the document domain a property to the same main domain, then you can actually disable SOP as well, at least partially. And this also doesn't sound like you would. Oops. Okay.
Oh, now you
like
broke
you
it.
would actually have to do that. That it's very common, but I've seen this actually in some external JavaScript that was loaded on pages, and I was wondering actually what it does when I saw it the first time, because this kind of looks weird to me. It's just setting the value to the value it already is, but it will enable this behavior. And then we also have postMessage, with which I will explain here. What we can do now is when we exploit this, we have XSS on the main domain, and from that was issued from a completely different origin. The problem here is it's kind of similar like of deserialization vulnerabilities. If you have a handler for postMessage, it's not very dangerous, except you do something dangerous with the data you receive. And this is also often the case because it's often trusted. The same works the other way around. If we have something like this would load the same again, and then do http attacker.ns. I think it's postMessage frame child. Yeah, that works as well. So we just stole the data that was meant to be sent to the other frame that was loaded before in this space here. And this is actually also quite common. I will show you how that works in the slides now. So let's first talk about what happened with JSONP. It's just a way to format JSON in order to include it with a script tag, as I said. And the format is like this, the callback and then the JSON object. And developers need to create the JavaScript function called callback in this specific example. And after the function is defined, they can include the formatted JSON from above with a script tag, and the function is called with that data. And it works since JSON has the same format as JavaScript objects. Then cross-origin resource sharing. It's a set of headers that enables cross-origin requests. We have the access control allow origin header, can either be an origin or wildcard by default, except if you use it with access control allow credentials. That allows browsers to send cookies along with the request and makes it actually dangerous. The cookies can be sent without using calls as well, actually, but you can't read the responses then. And as I said, can't be used with a wildcard. The common mistake I showed you is that the origin is automatically added. Then we have setting document domain to the same value, and subdomains can set the value of document domain to the same main domain. And example.com wants to communicate it with doc.example.com through an iframe, then both set the document domain property to example.com. That disables SOP partially, and sites can communicate through the iframe or actually any window object. This is dangerous if you have an XSS vulnerability in a subdomain, or if you allow users to add their own JavaScript on dedicated subdomains. And as I said, it's sometimes found as document domain equals document domain in external scripts or libraries. And sometimes you aren't even aware that this is set, or don't know what it does actually, because it looks kind of harmless. And last but not least, the postMessage API. This is a JavaScript API that allows sending data to cross-origin iframes and windows. And the target side needs an event listener called message. So it looks like this. And as you see, it doesn't check where the data came from by default. You have to do that yourself. And if you want to send a post message, that is something completely different because you actually have to specify the origin. But unfortunately, you can use a wildcard here again. And for the listener, you have to use the message origin property to actually check if the origin is the one you intended to receive the data from. And the last one is kind of dangerous with the wildcard because an attacker maybe manages to redirect the window, and then the data will just be sent to the attacker. Exactly. So this was my presentation. And as you see, it's just kind of easy to get these things wrong. Those are powerful tools because they can disable the same origin policy, but you have to use them with care because it's just so easy to mess it up.
Clearly, and Sven, as you said, developers love to use wildcards. And
that is true.
I heard wildcards in there a couple of times, and what could possibly go wrong with that?
Yeah, I mean, you specify the origin, and it doesn't work the first time, and then you type in the asterisk character, and everything works perfectly. So why not keep it that way?
Exactly. Yeah, when you can't figure out what you need to allow, just allow everything.
Exactly.
Yep. Default permit. IP any, right, Joff?
Oh yeah. Hey, I'm here. Where did I come from?
The magic of the internet. So
a beautiful thing.
So Joff, Keith, any questions for Sven?
Yeah, I mean, Joff, if you're welcome to go first. I mean, I run the Application Security Weekly show on the podcast network, so I'm happy to let anyone else go in first before I've got a few pointed questions.
Listen to Keith bragging.
Sorry.
Okay.
Sorry, I had
so
to.
I have a wicked echo, first of all. But, the question was, in HTML5, is there any big changes coming, or beyond HTML5? Is there any big changes coming to the same origin policy?
I don't know of any actually. I mean, we have the postMessage API, which is kind of powerful if you use it correctly, and it just together with CORS, it solves a lot of problems you have with SOP actually. So if you use it correctly, and it's possible to use it correctly actually, it's pretty easy as well if you know how to do it. Then it's a pretty good tool to SOP if you intend to make your data accessible.
I got you. So it's just enhancements in terms of the various protocol elements that you have accessible to you.
Can you repeat that? I didn't get that the part.
Yeah, I think your connection's dropping a little bit. So what you're saying is they're just additional enhancements in terms of the protocol with all the additional headers that you can pass back and forth.
Yeah.
All right, Keith, looks like you're up, man.
All right,
Keith, shoot.
So Sven, I'm curious to know, especially so the examples that you were using, like they were in PHP, which as we I think all know as hosts and yourself at Netsparker know, is generally a pretty bad language for security purposes. I'm curious to know, especially with modern frameworks, especially like modern JavaScript frameworks, are there any that are doing the sort of like SOP or CORS whitelisting really well, or any that are doing maybe really badly that you'd call out?
I don't know too much about them actually, but from what I generally know about these frameworks is that they are they handle a lot of that stuff for you actually. And you have these JavaScript frameworks where you can just add some modules and have all your functionality added automatically actually. And there are some for cores, and I think they are quite good actually. And there's not too much you can do wrong with them. And it's especially any JavaScript framework is better for that stuff than PHP. It's just it depends what you want to do with it. And in PHP you have to do a lot of that stuff alone because there aren't any native functions you can use to just set your core setters and stuff, and you have to handle that yourself. And there are a lot of pitfalls you can fall in, and I think that is way better with some JavaScript frameworks than with vanilla PHP.
And in your experience as a researcher, because I know you've done a lot in terms of Chrome's XSS auditor and in doing bypasses and such, are you seeing less PHP over time in some of the like research and testing that you're doing, or is it still pretty prevalent? I know, I mean, WordPress is written in PHP, so that's everywhere. But beyond WordPress, is PHP starting to die off in your experience, or is it still kind of prevalent and lurking out there?
From my experience, it's getting way less. There's I think the reason for that is not only that PHP is considered as an insecure language, which it is actually in some aspects, because it's just for some stuff incredibly difficult to get it right. If you use HTML entities, the HTML entities function, for example, it just doesn't encode the single quotes by default, which is kind of weird. I think it makes some sense if you read why it is that way, but it's just very counterintuitive. And you just see a lot of these JavaScript projects actually taking the place of other projects that were in PHP before. I think it was kind of like that with Ruby on Rails before. That did a lot of that stuff, but that is dying off as well. I think it's getting less too. So I think there will be more.
Okay, Keith, any more? Or are you good?
No, honestly, I mean, it's interesting because my experience has been somewhat the same in terms of PHP kind of going the way of the dinosaur. So, yeah, nothing else on my end, honestly.
Hopefully, maybe we've beaten the PHP horse to death and have pushed folks to other more secure frameworks for developing web apps. This said, when I just start looking at some new products that are in PHP that are like, wow, that's really cool and we need that, but it's in PHP. Really? In any
so
case,
many better choices.
Oh, of course. But
well, and it's interesting too, though. I recently was working on a site built in Vue.js, and they actually had some cores packaging specific to what Vue.js is trying to do that actually does it insecurely. And a lot of like the free code camp guides and other guides out there are like, yeah, just import this module, or you add this to your package.json and you're fine. And you're like, wait a minute, this is allowing cross-origin resource sharing everywhere. Like if I'm accepting inputs, this is really, really bad. And yet that's kind of the default for some of the modern frameworks like Vue.js. So it's kind of like a situation where if the developers don't really know what it's doing and they're effectively allowing any, yeah, the world is still interesting in bad ways, to say the least.
Awesome. Well, Sven, thank you so much again for coming back on Security Weekly. I for one, enjoy every time that you were on the show because I learned so much. I would far from consider myself a web application expert and or pen testing expert. So I pick up something every time you're here. So again, thank you again for coming on Security Weekly, and I can't wait to have you back again.
Thank you very much.
Welcome. Now, go get some sleep, and we'll come back with Stories of the Week.